Hello everybody. Today I am going to demonstrate some additional capabilities of HSPEXP+. In a previous video, I demonstrated how HSPEXP+ can be used for hydrology calibration. In this video, we'll demonstrate how to use it for generating water balance report. We are going to look at the exact same model, hyd_exp.uci, that we use for the hydrology calibration. Let's look at the model quickly. The UCI file here shows that the output is written to a binary file, a binary output to file number 92, and the name of the file is hyd_exp.hpn. You can have as many binary files as you want. If you look at the binary info tables, we see that for the pervious land operations, output is written at monthly interval, and for the file number 92, all the operations have specific names. Those are the land use names. Again, for the impervious areas, output is written at 4, that is a monthly interval, to the same file number 92. For the reachless operation, all the reaches 1 to 6, the output is written at 4, monthly interval, to the file number 92. Then we'll start HSPEXP+. Since I already used HSPEXP+ for hyd_exp.uci, that UCI file is already loaded. We'll just load it again. So now it has multiple checkboxes. We want to run HSPF again. I want to generate watershed area reports, so I'll show you how that works. The analysis period is from 1986 to 1988. In some cases, modelers may like to run it for longer period and analyze for miss couple of first years for analysis because they want the initial conditions to set up. So in this case, if I want, I can change it to 1987. So although the model will run from 1986 to 88 as specified in the UCI file, the analysis will be done on the last 2 years only. Then I want to check box for water. I also want to generate, so this constituent balance report will be generated for water for the entire watershed. I want to generate specific reports until the reach 5 as well. I'll show you how those reports look like. Click on start. Since it's a small model, it will run quickly. So the first folder that we'll look is area reports. In area reports, it shows that for until reach 1, there are only 4 land users that are contributing. And then there's impervious area, about 18,000 acres is contributed. If you have a GIS file for this model, then you can compare it to make sure that your UCI file is actually representing all the areas. A word of caution, in some cases some reaches have multiple diversions, or it may divert and join back the model. Those are in those complicated models, these area reports may not be very accurate, and sometimes the constituent balance reports may not be accurate either. So I would suggest you to exercise caution in those cases. There are multiple reports here. One of the report is operation per year, that shows that for 1987 and 1988, only 2 years we use for analysis. How much is the rainfall is happening, how much of that is surface runoff, interflow, base flow in total. And we can go further down and look at for reaches. It tells you how much of water flowed in, how much water flowed out, how much was the surface precipitation, this is in acre feet, how much was the surface precipitation, and how much water evaporated from that reach. There's another report that is water land loadings. This is a detailed report that you can open in Excel or LibreOffice. And this is a tabular representation where you can use filters to look at specific parts of the report and extract it more easily. For example, go here and use filter. Instead of looking at each year, I'll just look at sum annual. And instead of looking at all the land uses, I can just choose to look at forest only. This is simple filter capabilities, and then it tells you how much was the surface flow in inches, how much is the interflow, outflow, groundwater outflow, and what are the different places from which the water evaporated. Additionally, a box whisker plot is generated that tells you how much water ran off as a runoff in inches per year. So for example, in this case, from the forest, about 7 inches of water was total runoff. Same amount of water was running off from wetlands, so you may have to change parameterization. That's a detail that is not covered in this video. If you had same land use for multiple operations, you may get a box whisker plot like this. So in this case, you'll see that there are multiple operations and with the land use undisturbed forest, and that resulted in this box whisker plot. As you can see, impervious areas are causing higher runoff and pervious areas are causing lower runoff. It also generates monthly loading reports. So for example, for forest land, we see much of the runoff happening in winter months and very low runoff happening in the summer, late summer and fall months. If you have multiple land uses, you can also see it that in this case, I think there were 3 or 4 forest land uses, or probably more. So, but in this case, we are seeing low runoff in summer and late fall, and then higher runoff in winter, and then highest runoff in the month of May. You may use this information to improve the model. The way we generated water balance report, the same way we can generate the report for sediment, total nitrogen, total phosphorus, BOD labile, dissolved oxygen and heat. If you are simulating additional constituents as G-qual, like fecal coliform, metals, then additional check boxes become active here, and you have to click on those check boxes to generate report for fecal coliform or metals or any other constituent that you may have simulated. Now, there are multiple reports, as I said earlier. A lot of these reports are the same, but they are formatted differently, presented differently, so that you can take out the information that you need. And then in some cases, you may have to go and look in the individual details of if something went wrong, where it went wrong, or what land use may have wrong parameterization. I hope this helps you understand how to generate water balance report and how to use that information in hydrology calibration, and then you can generate similar way nutrient calibration reports and use that for nutrient calibration. If you have any questions, please feel free to ask in the comment box below. Let me know if this video is helpful. Thank you.